Okay, so we're gonna do 4-4. We're gonna do rational root theorem. All right, so what are rational numbers before we keep going?
Fractions.
Fractions, good. Okay, so go ahead and hit enter. So I kind of touched on this the other day. So this is when we're gonna do the P over Q, and we gotta figure out where P is and where Q is. Do you remember doing this? This is all the possibilities of the roots that would work in this equation. And what are roots?
Where it crosses the x-axis.
Good, okay, and anything that causes that to go to 0, right? All right, so this is just going to tell you the rational root theorem, P over Q. Now let's remember, where do we find P? P is what?
Factor of
A sub n. Where do we find A sub n in this polynomial?
The B, is that B?
It's an A. It's like a lowercase a.
Yeah, so like, is it the C then?
That's a T.
That's what I meant.
You're thinking
not
of.
B.
Mhm.
Yeah.
Yeah, so this is always going to be the P, okay? What we think of as the y-intercept.
Yes.
So where do we find Q?
The beginning.
What's that called? What is this called? What's this number called?
The co-leading coefficient.
Leading coefficient, okay? So Q is going to be my leading coefficient. P is always going to be the y-intercept, all right? What they want us to do is determine the rational roots, which means I will put P over Q. So the easiest way to do this is to list all the factors of P. So we want all the factors of 2, which would be plus or minus 1, plus or minus 2. Do you agree? Then we have to do the same thing for Q. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? Now, they want us to list all the possibilities, every possibility that we possibly are going to get, which would be P over Q. Okay? The easiest way is to just take 1 over everything, then move over to 2 over everything. So plus or minus 1 over 1, 1 over 2, 1 over 3, 1 over 6, and then move on to 2. Plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 2 over 3, plus or minus 2 over 6. Now, some of these reduce and they're repeats. Do you agree? Like this reduces to 1, this reduces to 1.
Yeah.
Okay? This reduces to 1/3. We already have 1/3. Okay? So, and that's okay. Okay? It says then determine the rational root. So it wants to know the actual roots. We're going to speed this process up a little bit. How are we going to speed it up? What do you guys think? Rather than trying every single one of these, what can we use to help speed this up?
Grouping them, factoring, setting it.
What utensils do we have that might help us narrow this down? Yeah, graphing calculator. Okay, so go ahead and throw this equation in your graphing calculator and let's look at where it crosses. It's probably not going to cross at an actual whole number. Okay, so but we have what they have to be. They either have to be at a 1/2, a 1/3, or 1/6. And if we use our trace button, we can probably get pretty close to figuring out which one these are.
Give me a minute. A hot minute.
Anybody got one?
-1.
You think, okay, so she said -1 has to be one of them. Another one?
Like 1/3.
She thinks maybe 1/3. Okay. Well, let's try -1. So let's do our synthetic division. See if it'll give us something, a depressed polynomial that we can factor. So let's do 6, 11, -3, -2. Bring our 6 down, that's -6, 5, 2. Was it -1? That should have been a negative.
I think it's 1 and -1.
Did I not do that right?
Okay, I did something wrong.
Are you sure -1 was one of them?
I don't know
I
what
mean,
you're
if
talking
you
about.
look at it,
Taylor, show me yours.
No.
Yeah, it does look like -1 to me too.
It's right on the one?
I mean,
Okay,
that's what it
how
looks
could we
like.
find out? We could look at our,
If you zoom in, it's at -1/3,
a -2/3 or a negative,
or -1/3.
let me see yours.
It looks like +1.
yeah,
Okay.
it is -1 because if you look at your table,
Okay, let's look at your y equals. Are you sure you guys have them in there right? Because his is different.
yeah, it doesn't look like -1 anymore. I don't know.
This looks like -2.
I was thinking positive.
Isn't that -2?
Yep, this is like -2.
Let me see what you want.
Yeah, it's -2. Okay, so -2 works. Did you hit a wrong number?
Okay, I'm doing this way
I
wrong.
don't. I think I put
I need help doing
Plus.
this, graphing this.
3x.
Okay. Are you, let me see what you put in. Bring it here. Let me look
I
at it.
think it might be the fact that I'm misusing negative and subtraction, but that's what I got.
Okay, 6x cubed plus 11x squared minus 3x minus 2. What's it saying? Is it graphing it?
Yeah. I'm
Yeah.
getting the right graph.
So where's it cross the x-axis?
-2.
Wouldn't it if it's -2? Wouldn't you take -2 times -1 and that would equal 2?
Oh.
So then you would get -1.
I was doing -2, I just didn't change it. Sorry.
You
Did I
need
mess
to
up?
fix- Stop. Right there. Yeah.
Thank you.
You're welcome.
Then that doesn't work.
Wait.
But that you were right.
No,
That was
no.
right. You just didn't. You added it. It should have been a positive.
So that, yeah, it should be +2.
There we go. Okay, thank you. So 6x squared minus x minus 1. Okay, so we want to see if this thing is factorable. I'm looking for factors of 6 and 1 that will give me -6. So let's make our little chart. So 1 and 6, 2 and 3, 1 and 1.
2 and 3.
2 and 3. So he says 2 and 3. Okay, so 2 and 3 need to equal -1. So -3 and +2.
2's has to be in the front. They have to be in the front, yeah.
Good. Okay, and 1 and 1 doesn't really matter, but we said that the 3 had to be negative. Okay, so x equals 1/2
And then -1.
and -1/3. Now look at your graph. Does it look like it hits at -1/3, 1/2, and at -2?
Yep.
Yes.
Good, good.
I think it's -1/2, wouldn't it be? Oh,
Positive.
you're right.
Now, are these found in here?
Yes.
Yes, they are. We had positive 1/2 and -1/3. And -2. Is it found in here?
Yes. 2 of 1.
Good. Okay. All right, go ahead and hit enter.
Oh, sorry.
Do we need to do another one?
Yeah.
Yeah? Okay, let's do another one. Okay, so let's do P, Q, and then P over Q. Okay, which one of these numbers is our P?
8.
Good, this is P. Okay, so plus or minus 1, plus or minus 2. Is 3 a factor?
No.
4,
Yes.
5,
No.
6,
No.
7, 8. What is our Q?
3.
3. Okay, this is our q. Okay, so plus or minus 1, plus or minus 3. Okay, and the next one we're going to do is p over q. So we're going to start with 1 over q, 2 over q, and then keep going and keep going. So plus or minus 1 over 1, 1 over 3. Now we're going to move to 2. Plus or minus 2 over 1, plus or minus 2 over 3. Now let's move on to 4, okay? Plus or minus 4 over 1, 4 over 3. And the last one we're going to do is 8. Plus or minus 8 over 1, plus or minus 8 over 3. Now, what can we use to help us out here? Graph it. Good, so go ahead and graph it. And hopefully it'll cross the axis at a specific point. Maybe 4, maybe 8, maybe 2,
Nope.
or 1.
1 and 4.
It does at 1 and 4. So she says 1 and 4 are possibilities. So let's go ahead and do 1, because 1's usually the easiest. So we're going to do our synthetic division, get a depressed polynomial.
And negative 2/3.
3. 1 times 3 is 3, negative 10. Times 1 is negative 10, that's positive 8 times 1. Did I miss a negative somewhere? 1, negative 3, negative 10, negative 10, negative 8. There we go, times negative 8. Okay, so it is a factor. Now, you said it crossed at 4 as well?
Yes.
Can I just go ahead, rather than going back to factoring it, can I just,
Yes.
again?
Yes.
Okay, oh, 4.
4.
Thank you. So I bring my 3 down. 4 times 3 is 12. That's 2. That's positive 8. 0. Good deal. Now, I've depressed this polynomial how many times? Twice. So this one would have been x squared. This one would just be x. So I have 3x plus 2. And if I set that equal to 0,
2/3.
Hey.
negative 2/3, right?
Yup, I guessed that.
And that's what Trustin said. He said when he looked at the graph, okay, and knowing that it had to be one of these, he said he thought it was negative 2/3. Good deal. So we found all of those for 1, 2/3. All of those were found in all of our possibilities. A little bit better? Okay, all right, go ahead and hit enter. Let's see what else we got here. Okay. Integral root theorem. Let's see what this one says. It's a polynomial equation that has a leading coefficient of 1. Okay, this is just a fancy way of saying if our leading coefficient is 1, okay? This is my P, this is my Q, okay? Now let's think about this. If we do everything P over Q, it's gonna be all the factors of this over what?
1.
1. This theorem is just a fancy way of saying if I do that same process and I have it over 1, I'm gonna be just left with integrals, 1 and 5. That's all it is. It's nothing any different than what we did. We know the factors, so it would just be plus or minus 1 over 1, which is equivalent to 1 and 5. That's all it's saying, okay? Any number, if we throw it over 1, becomes a rational number, okay? Do you want to do this one, or do you feel pretty confident? You want to do this one?
Let's do it.
Okay, we'll go ahead and graph it. We know we have to have, it's got to cross this at what, 1 or 5, right? Or possibly both.
Wait.
So it's x cubed plus 8x squared plus 16x plus 5.
Got negative 5.
Yeah.
You got negative
I
5?
have negative 5 too.
Okay, so x equals negative 5. Okay, so let's throw this thing in here and do synthetic division. So 1, 8, 16, 5. Negative 5, that's a positive 3. Negative 15, positive 1.
That works.
Good, okay. So this becomes x squared plus 3x plus 1.
You could try 2.5 or
Quadratic.
negative 1/3 or negative 2.5.
Okay, Molly says let's use the quadratic formula, okay? She says she sees it's not factorable. I really don't want to spend a bunch of time throwing some random numbers out there, okay? All right, so x equals negative b, what's my b?
3.
Plus or minus b squared minus 4, what's my a? And my c, all over 2a, which is 1. So negative 3 plus or minus, what is 3 squared?
9.
And 9 minus 4?
5.
So the square root of 5, all over 2. Can I reduce that at all? No. No. Does it? Are these real or complex?
Complex.
Complex.
Real.
They're real.
They're real.
I.
If I had an I, yeah. If I had a negative under here and I had to pull an I out, then they would become complex. But as of right now, how many roots do they have? Does this thing have? How many real roots?
2.
Oh,
3.
3. Because it has to add up to our leading coefficient. Good. Okay. Okay. All right, go ahead and hit enter.
This is crazy.
Do we need to do another one like that?
No.
Okay, go ahead and hit enter. Okay, so this is Descartes' rule of signs. This is not hard, okay? It says, suppose that I have this polynomial whose terms are arranged in descending powers, meaning it goes from 5, 4, 3, 2, 1, and none, okay? It says, then the number of positive real zeros, okay, so that's gonna be important. So positive real zeros is the same as the number of changes in signs of the coefficients, okay? And can be reduced by 2 each step, okay? So let's look at what that means. If I look at this one right here, this is a positive 2 to a positive 3. Was there a change
Yes, 1.
in signs?
No.
Both positive, so no change. From positive 3 to negative 6, did the signs change?
Yes.
Yes, okay. What about from negative to positive?
Yes.
Yes.
Okay, and positive to negative?
Yes.
Okay, negative to positive?
Yes.
Okay, so what this says is that positive real zeros, okay, how many changes did I have? How many yeses?
4.
So there's a possibility of 4, and we're gonna reduce it by even numbers down, so there's a possibility of 4, 2, or none positive real zeros. Yes, so that just means it's gonna cross the x-axis, a possibility of 4, 2, or none on the positive side of the x-axis, right? Now, it says the number of negative real zeros is the same number of changes in the signs, okay? This time we're gonna plug in p of negative x, okay? So, before we do this, the first thing we're gonna do is do 2, and we're gonna replace each of those x's with a negative. Okay, this is not the same as just going through and negating everything. Okay, so do not make that mistake. If you do, you're not going to get the right answer. If I take a negative variable to an odd power, what's it gonna leave me with?
Negative.
Negative. So this is negative 2x to the 5th. Okay. What about here? It's to an even power.
Positive.
Good. So 3x to the 4th. Here I'm gonna have to an odd power, so it's gonna be negative times a negative 6, makes it positive. Good. 6x cubed. Here I have it to an even power, so plus 6x squared. Negative and a negative makes a positive, plus 3. Now, to figure out our negative real zeros, possibles, we're gonna do the same thing. Did this change? It goes from negative to positive. Is there a change? Yes. Positive to positive?
No.
Positive to positive?
No.
Positive to positive?
No.
Positive to positive. So the possibility here is 1 real negative. Anybody see a correlation between these and these?
They just swapped.
They just swapped, okay? So one way to double check yourself is if you have a yes and a yes in the same spots when you do this, you've done something wrong, okay? You should only have a no versus a yes and a no versus a yes. You should never have a yes, yes in the same spot. If you did, you've done something wrong, okay? So that's Descartes' rule of signs. This is basically just gonna tell us our possibilities. If it's an even number, we count down by 2s, okay? So far, so good? Okay, go ahead and hit enter. Do you wanna do another one or you feel good about that one?
I can only do another one.
Wanna do another one? Okay, so let's look at this one. So the first time we could leave it as is. So it goes from positive to negative. Is there a change? Yes.
No.
Okay, he says no, negative to negative.
Yes.
Yes.
No.
No. Okay. Now, so how many yeses did I get?
2.
So there's a possibility of 2, that's an even number. So I count down by 2s, or 0, positive, real roots. Okay? Anybody want to take a guess at what our negative real roots possibly are going to be?
2.
Yeah,
0.
because these should flip-flop, but let's plug them in just to make sure. Okay, so it's gonna be 2.
Why are you leaving little space in there?
Because I'm gonna make them pretty so that you can see what we have changed. Beautimous, right? Okay, when I take a negative to an even power, it goes positive. So 2x to the 4th. To an odd power is negative, and a negative times a negative makes a positive. Good. This becomes a positive times a negative,
Negative.
and a positive times a negative
Negative.
plus 1. Okay. Now we're gonna see what kind of changes we've got going on here. So I've got positive to positive,
No.
positive to negative,
Yes.
Yes.
negative to negative,
No.
and negative to positive.
Yes.
Good. Okay. And this alternated, it flipped it, right? It flipped every single one. So there's my check and balance to make sure that I've done it right. If I have any of these that are the same, something's wrong at one of those points. Now, how many yeses do I have?
2.
So I have a possibility of 2
Or
or 0,
Real.
negative, real roots. Good.
And that's 100% accurate.
We'll graph it.
I don't know.
You definitely graph it. Throw it in your calculator and
You
check.
have to do PQ.
Nope, you don't have to, huh? Basically, you're gonna graph this and look, you're either gonna have 2 or none for your positive reals, or you're gonna have 2 or none for your negative reals. You should not get anything any different than that. You shouldn't get like 3 real positive roots.
I think you're gonna get 2 of both because.
Well, is that
It's
possible?
Yep.
It is possible. It's a possibility because there is a power of 4 there. Highest power is 4.
But, I mean, if you get 0 of one.
So what'd you get,
that's
Molly?
too complex.
I got 2 roots,
Okay, positive or negatives?
negatives.
2 negatives.
Yeah.
Okay, so she got 2 negative real roots.
I think it's
And then
0.
So that,
Zero positive or root.
and there was 0 positive. So how many roots are still left out there?
2.
2, so they have to be 2 complex. Good. Good. Okay, go ahead and hit enter. I think that was it,
Yeah,
wasn't
that
it? Okay, so go back to that page number real quick. Okay, so you're gonna work on the problems that are on page 234 handout. Okay, so kind of work on those. Jordan, will you go ahead and hit stop for me, please?